Greetings, fellow muckers. Today, we're going to be going over the substitution rule. The problem. Find the following indefinite integrals. In part A, the integral x to the fourth times x to the fifth plus 6 to the ninth dx. In part B, the integral cosine to the third of x times sine of x dx. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you're able to solve this problem. Now let's work on it together. So in part A, we need to find the indefinite integral for the integral of x to the fourth times x to the fifth plus 6 to the ninth dx. So in part A, what will be our u? U in part A is going to be equal to x to the fifth plus 6. Therefore, our du is going to be equal to 5. We can take the derivative of u, so we get 5x to the fourth dx. So, we see that we have a x to the fourth, but we do not have a 5. So what do we have to do to implement our du into our integral? Well, we need to rewrite du equal to 5x to the fourth dx as x to the fourth dx is going to be equal to 1/5 du. So what happens is we need to divide by 5 on both sides to remove our constant from our x to the fourth. So we have x to the fourth dx as represented or shown in our integral. So now all we gotta do is plug in what we have done. So if we do that, our integral becomes, so now this is going to be equal to the integral of u. So we place x to the fifth plus 6 with our u to the ninth times, now we replace x to the fourth dx with 1/5 du. We can take our constant out, so this is going to be equal to 1/5 times the integral of u to the ninth du. And now we could take our integral of u to the ninth, so this is going to be equal to 1/5 times u to the 10th divided by 10 plus c. And now all we're going to have to do is times our denominator, 1/5 times 10. So we have 1/50 times our integral now. Or now we just plug in for u, or u, which was x to the fifth, plus 6 to the 10th, plus c. And this will be our solution for part A. So the indefinite integral of the integral x to the fourth times x to the fifth plus 6 to the ninth dx, it will be equal to 1/50th times x to the fifth plus 6 to the 10th plus c. And now in part B, we need to find the indefinite integral for the integral of cosine to the third of x times sine of x dx. So in part B, what will be our u? U will be equal to cosine of x. And what will be our du in this case? Well, the derivative of cosine of x will be equal to negative sine of x dx. So now our constant out in front will be a -1 essentially. So we have negative. So to fix this, all we do is divide both sides by -1. So we'll get sine of x dx. It will be equal to negative du. So if we do this, if we plug in our u and du into our integral, this will be equal to negative. I'm just going to pull out the negative immediately from our du. So we get negative, and then cosine to the third of x. Well, we have u equal to cosine of x, so we get u to the third. And as I stated, sine of x dx is equal to negative du. So I put a constant negative out in front of the integral. So we're just left with du. Now if we just take our integral of u to the third du, we are left with negative u to the fourth divided by 4 plus c. So now all we have to do is plug in our u back into our answer, and we're left with negative cosine to the fourth of x divided by 4 plus c. And this will be our solution for part B. So as you see, our answer for part B, for the indefinite integral of cosine to the third of x, sine of x dx, will be equal to negative cosine to the fourth of x divided by 4 plus c. I hope this video helped. If it did, please consider subscribing and liking this video. Thank you.